What I want to do in this set of videos is illustrate the difference in node voltage and mesh current. I think there's a lot of times when students who are first learning circuits are not clear on whether to use node voltage or mesh current. So we'll just work some problems setting it up both ways and let you look at what the difference is. So I'm going to start with this problem right here, and we'll first work what a person would want to know here is what is the current I-phi. So we'll set it up like we would work it using node voltage. So this has two voltage sources. I'm going to identify the common ground between the two. One of them is a voltage source. I'll have V1, V2, V3, and V4. V1 will be 20 volts. V4 will be 8 I-phi, and that's volts as well. I-phi, in terms of the node voltages, is V2. It's the current through that 5 ohm resistor going from left to right. So it's V2 minus V3 over 5 ohms. So that is all the non-node equations, leaving two node equations that need to be written, one at node 2 and one at node 3. So at node 2, I have V2 minus V1, which is 20 volts, over 2, plus V2 over 20, plus V2 minus V3 over 5 is equal to 0. And then at node 3, I have V3 minus V2 over 5 plus V3 over 10 plus V3 minus V4, which is 8 I-phi, substituting directly, over 2 is equal to 0. I do want to make one comment. It's really important when you write node voltage equations to say that it's equal to 0. Otherwise, it's not an equation. It can't be solved. So remember, node voltage is based on KCL, that the sum of the currents around any closed, the sum of the currents in any closed surface is equal to 0. So now I have, in these three equations, get a different color of pen. In these three equations here, I have three equations and three unknowns. So I did put up a video on solving simultaneous equations. At this point, for expedience sake, I want to teach node voltage compared to mesh current. If someone requests that I put up a video where we actually solve one of these all the way to completion, I can do that as well, especially if it's requested, say, by next time we have a meeting. This is not the same problem. So let me see. Let's go back here and let's insert a new slide. And let's get rid of this. And we'll get rid of this. And then let's come back to the problem we just worked. And select this figure. And we'll paste it here. And now let's look at doing the same thing with mesh current. And then you can just look at the equations and determine, which one you think is easier. So we'll start out with blue again. So mesh current, we need to come in and define our three meshes. I1, I2, and I3. And so our mesh current equations around mesh 1 will have minus 20 plus 2I1 plus 20 I1 minus I2, that's equal to 0. Around mesh 2, we'll have 20, and this time, since we're in mesh 2, it's I2 minus I1, and we'll have 5 I2, and we'll have 10 I2 minus I3, and then mesh 3, we'll have 10, and this time, since we're going around mesh 3, it's I3 minus I2 plus 2 I3, and the 8I phi is a voltage source, and it is a drop. It's a dependent voltage source, but it is a drop, so it enters as positive. Now we need a dependent source equation, and our dependent source variable is I phi. So if we find I phi in our circuit, it's right here, and we can see that it's the same as I2. So you can rewrite and rearrange. Actually, you can substitute directly for I phi.